Hi, good evening. I'm Abhilash here. Today we are going to discuss about Euclid division algorithm. It is also called as Euclid division lemma. And the simple steps is it is used to obtain highest common factor between two positive integers. So the definition is to obtain highest common factor of two positive integers, either C and D or A and B. You can consider any alphabets where one should be greater than another one. Here for example C is greater than D. To find the highest common factor between the integers C and D, we need to follow the steps. For example, this is actually algorithm. The first step is the Euclid division algorithm has to be applied to the integers C and D to find Q and R. The initial steps is to find Q and R, where Q is quotient and R is the remainder, and it will be formed in this manner, where C is equal to the relation between C and D with the new variables Q and R is formed like this. C is equal to dq plus R, where the remainder will lies in between 0 to D. We can examine this in this manner. As we discussed, C is equal to dq plus R. If you remember the normal division method, like for example, if you want to divide 3 with 10, here 3 is called divisor, where 10 is called dividend, and this part is called quotient. So after 3 3s are 10, if you want to subtract, 9, if you want to subtract, the 1 is called remainder. So these are the 4 keywords when you want to do division to particular two positive integers. So we have 4 terminologies here: divisor, dividend, quotient and remainder. So that's what we are going to represent. C is the divisor and D is the dividend, Q is the quotient and R is the remainder, where R exists in between 0 to the quotient. 0 is less than or equal to R, less than the divisor C. The divisor C. Like this it will be formed. R exists in between 0 to C. And next, that is what the first step. R is less than or equal to R, less than D. It lies, D is nothing but here divisor. It will be less than this number and this number both, because you are dividing with the C. And next, so the second step is, if R is equal to 0, means if the remainder is 0. For example, if you want to find the highest common factor between 4 to 12, what happens? If you are dividing with 4 to 12, 4 3s are 12, you will get remainder 0, which means 12 is equal to 4 times 3 plus 0 is the remainder. So wherever you are getting remainder 0, you can consider that at that point you are obtaining the highest common factor between the two positive integers in the given question. So in this question we have 4 and 12. For this, the quotient whatever you got, that is the HCF. So means 3 is the HCF wherever you are obtaining remainder 0 between 4 and 12. Let us try one more example. If you want to give a try between 3 and 15, you can imagine 15 is greater than 3. This is the first step and first condition, where C should be greater than D or D should be greater than C. So either the way, one number should be greater than another. That's the first condition. And second condition is you need to obtain where c is equal to dq plus r form. So if you do the division with 3 to the 15, you can obtain 3 5s are 15 and 0 as the remainder. So as we discussed in this second step, wherever you get the remainder 0, you can consider that at that point the quotient will become the highest common factor between the two numbers. Means here 15 is equal to 3 into 5 plus 0, remainder 0. Means you can say d is equal to cq plus r, or c is equal to dq plus r. So here highest HCF is at this point 5. Let us see one more example. 99 15. So let us try to find this 99 with 15. So we can obtain the nearest number to the 99 in the 15 table 6 times. So 15 6 90 will go, and the remainder 9 will come down. This will be the next divisor, and the dividend will be the previous divisor 15. And now 9 ones are 9, the nearest number, and 9 twos are 18 will go the higher value compared to the given number. So we have to take the less number. So 9 ones are 9, and we have 6 as the remainder. At the